Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in London. We are broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic, Rosetta Zoo. We'll be back in 8.3 seconds. I think we have a listener. Thank you so much for joining us, Scott.
Yep.
Nice to see you. Glad you're here. All right, so tonight we're going to show you how to help scientists by listing the changes on Comet 67P. Jeff takes point on this topic tonight. Over to you, Jeff. And just so you know, Scott, it's not counting rocks.
No, it's in some ways it's better, and in some ways it's worse.
Okay.
This is another Zooniverse project. It's Rosetta Zoo, and so you've got the typical Zooniverse. There, make it a little bit cleaner looking. Got this typical Zooniverse website here. The title, about, classify, talk, collect. You've all seen this dozens of times already.
And there's the link.
Yep. Oh, and you're gonna have to look at comments.
Yeah, I can
okay.
tell.
These are the types of images that you'll be looking at, and as of the time of the slide, it's only 31% complete. And I've got to say, there's a reason for that.
Hi, Cliff. Thanks for joining us.
Yeah, hi, Cliff. These are really interesting images, and they don't ask for too much per image, unlike what Scott was going through with counting craters, or counting rocks. But the user interface controls are just so fiddly. They drove me nuts. But we will. I'll get to that later.
Yeah, I think it is very interesting, Cliff. But Jeff will have more information.
Yeah. Yeah. Okay. So about Rosetta Zoo, they sent the Rosetta spacecraft to Comet 67P, named after these people. You guys go for it.
Yeah, I think this is just scrolling down that link we shared in the chat.
This is all the first page. Yeah,
and that should be a clickable link in the chat now.
Yeah. Okay. And basically, they're taking images of it for 2 years.
Hey, Dan's here.
Hey, Dan.
Hi, Dan. Thanks for joining us.
Yeah. So they've got 2 years worth of images, and what they did was,
that's a lot.
Yeah. If they have images of the same spot from 2 different times, they post them side by side, and that, and then you compare things in the images. So, on the about page, research, basically what we talked about, Rosetta is a European Space Agency mission set off in 2004. Rosetta reached the comet in 2014, so it took about 10 years to get there. And the comet has a 7-year cycle. So they wanted one that they knew was coming around and had a relatively short period.
Okay.
Because that way the vehicle would be able to transmit to us easily, before it went way off into the weeds.
Okay.
And here's a bunch of images. You've all seen these, the rubber ducky image here.
I hadn't heard that before.
Oh, it was a common thing that they but so this just shows it's not just a ball of ice that's going around the moon, or going around the sun. It's this lump of things that basically ran into each other and are now headed this way. And here are some images taken by the Rosetta. Okay. um, and they found some nitrogen, noble gases, neon and xenon. All interesting stuff about Rosetta, and you can find out more about Rosetta. That has nothing to do with what we're doing, but they also did find some proteins.
Well, and that's what I like about Zooniverse. They have a lot of information.
Yeah, a lot of background.
Oh, Cliff had a comet. Yep, looks like a duck.
Yeah.
I don't think it quacks like a duck, though, so it must not be a duck.
Yeah.
Yeah, but in Zooniverse, you can actually chat with people. I don't know about the project.
Yeah.
The people running the project. Can you chat with them in the forums and stuff?
Well, as I'll show a little bit later, they do give a lot of email addresses.
Oh, that's cool. So yeah, if you had some more questions, I would say contact them.
Yeah.
And ask them.
So what's being researched and why is it important? Essentially, they're looking at early universe stuff, how things change, and by seeing how the comet changes as stuff evaporates off of it from being near the sun. They want to see that process. It's the first real deep look at a comet that we've gotten.
Oh, very cool.
And not just yeah, no, this is not 80 miles.
Oh, that's Daniel's comet.
Daniel, yeah, that's a much bigger comet than this one. This one,
I hadn't really heard about that.
Yeah,
I don't think
it's somewhere else in this section, but the comet itself is about 4 to 4.5 kilometers wide.
Cliff, always love to hear from you, Cliff. But if it quacks, can anyone hear it?
Yeah.
Maybe not.
Spacecraft. Okay.
All right, so it's important.
Yeah. It's basically why it's important is because it teaches us about the comets. The images are fairly high resolution. 1 pixel is 1 meter.
Okay.
So that's the kind of stuff that we're seeing there. And one of the things that they found, and one of the things that we're going to be looking for, are boulders that move. Now, it would have been nice if they'd have scaled both of these images the same, but this is old picture, new picture, and this boulder here moved from here to here.
Yeah, it looks like they have a dotted line around it. Yeah.
Yeah. So this is the kind of thing that they're looking for, because why would a boulder move? My guess is sublimation underneath it caused it to jump up, but not with enough force to actually leave. So it came back down. That's just my guess.
So this thing does have some gravity.
Oh yeah, some.
To pull the.
Yeah, but it's very weak. I mean, you could probably jump off it.
Right, but a boulder won't jump off.
Yeah,
of it.
Unless it. Yeah, and so more stuff. It's a primitive object. Can't really tell you exactly how things were in the early time because it's been changed by frequent passes by the sun. But it's still really, it's still some of the oldest stuff that we've been able to look at. So,
and I remember watching some, I think it were novas, and they could tell remarkable things even from, like Jupiter's come in and then left, and it's, gravitationally changed some of the orbits that are on the inner. I mean, there's all kinds of stuff they can deduce from.
Right.
Even like that. I mean,
yeah, they can deduce a lot of stuff.
Right.
The fact that Jupiter came in is still a theory, but it's basically it's a best fit theory so far. Yeah,
and that's how a lot of things go. Well, what works best, and then if but wait, this works better, and they change it.
And they get into it here and a little bit in other places. Why are people doing this? Because human eyes, there's a lot of noise in these pictures because they're not necessarily the same light level, the same time of quote day unquote, angle of the sun toward that section of the comet each time. So the shadows are different, so there's a lot of differences that aren't actually real differences.
And people have remarkable skills with pattern recognition, and computers just aren't there yet for that sort of thing. They're fast and they can compute, but
so that's
back to cool.
And how citizen scientists can help.
Cliff has a question.
Sure,
wonder if gravity from the sun. Moved the rock.
I doubt it, Cliff.
Well, there is the push of the photons from the sun,
right,
on some things, and it looks like it's big enough to get pushed, but I don't know.
The trouble with gravity as being the reason for the rock to move is that gravity would be pulling the comet at roughly the same rate that it's pulling the boulder. So they basically would be moving as a unit. Now, tidally, if the boulder was toward the sun, would the sun's gravity be pulling slightly heavier on the boulder than the comet? Yes, but it's such a small comet that the distance between the center of mass of the boulder and the center of mass of the comet is so small that I really don't think that would be it.
Okay.
It'd be, if you think about it, the moon raises our tides, so does the sun, but the sun's effect on our tides is so much smaller than the moon's, that, and that's something the size of the Earth. We're talking something the size of 4.5 kilometers, which is
that's
smaller.
The size of this comet?
Yeah, okay. Yeah, which is smaller than most towns, quite frankly,
Cliff does have a follow-up, or rolled in motion because of the sun. Yeah,
and here, another thing is that maybe it sublimated out of one side of it. If the sun was hitting the side of it, then maybe it kind of jetted it across.
As the comet rotated.
Yeah.
I was wondering if, I remember there's some boulders that move out in the desert, and they found out that it was because of the ice, and comets can have ice, so I don't know.
Yeah.
Oh, and here Scott goes with the gravity. Holding a boulder to the comet would be very small. Yeah.
Yeah. Yeah. It just, the difference is, so any kind of small force would do it. I don't think it would be gravity, but it could be solar wind, could be some little puff of gas from the boulder or from the comet,
okay.
or maybe some of the soil underneath that soil, I use the term loosely, evaporated because of the heat of the sun, and that caused it to slide to someplace else. They don't know yet, and none of this is getting into whys yet. They just want to catalog the changes so that they can try to figure out the whys.
Oh, very cool.
Yeah.
Okay.
So, so basically it's label each change and let them try to figure things out from there. And why not computers? This is 2 timed images, 2014, 2016.
And they're clearly the same location.
Yeah. But all of the red marks here are things that the computer says are in this image that are not in this image. All of the blue marks are things that are in this image that the computer says are not in this image. And quite frankly, they're all just slight shadow differences. So this is why computers aren't really good at this sort of thing.
Yeah. We do have a comment from Scott. Maybe a small meteor could move a rock.
Yeah. So. Oh, yeah. Heck, even if it doesn't hit the rock, but hits the comet itself, it'd be enough to bounce the comet, essentially, and the vibration could bounce the rock up.
Wow. Okay. I just love the audience comments here. That's great.
Yeah. And here's the team.
Very creative, very interesting.
Here's the team. And these are all clickable links here. So
cool.
You can actually talk to these people if you want.
Very good.
But there's about 3 pages worth of 4 pages worth of people.
Well, that's great. They have plenty of people now.
Yeah.
You ready for another comment?
Sure.
Yeah, ice formed under the rocks in Death Valley, and the wind blew them. It takes months.
Yep.
Right.
Yep.
But it's a possible explanation. I was just thinking, maybe it's like that.
Yeah. But yeah, it's possible. I mean, there's a lot of different explanations. But if they see a bunch of the rocks moving, then that gives them a clue as, then they can see what's the same or what's different in these rocks. Is there one reason they're moving or multiple reasons?
Yeah, there's a lot of work to go still, it sounds like. All right, we're ready for the next part here.
Okay, and the FAQ, where do these images come from? We already talked about that, but it has a link to the to a webpage with the Rosetta spacecraft, and
nice.
I went to hover over it to show you what the link was, and this is an image. That's not going to happen. Why this comet? Basically because it's there. I mean, that's essentially it.
Sounds like it was just in the right place at the right time, and
it would be in the right place at the right time when they were starting to build the vehicle. Why can't machines do this? They just showed it. What do they? What do they hope to accomplish? It allows us to understand how comets change.
Very cool. Yeah, a lot of information here. I would say check it out if you're interested in this project.
Yeah. Many of this. What will happen to the data? Well, they're going to have a lot of changes to sort through.
Yes.
Which will give them something to, like, if they put all of the, like, boulder changes, because it's not just boulders that we're looking at. We're looking at ridge lines that change, kind of like glaciers that cleave off, that sort of thing. Ridge lines changing. I mean, they'll probably make different categories of things and see the similarities and stuff like that and differences.
Yeah, and Cliff reiterates even gas escaping from under the surface as it warms.
Yeah.
And I think wasn't that what they were saying might possibly be?
No, that was my first.
Oh, that was okay, got it.
I wasn't actually reading, I was just inferring.
Plenty of theories. Cool.
Yeah, and that's just it. They've got lots of theories. They want to see if they can narrow it down. And most excitingly, maybe it's none of the things that we've talked about, because, there you go.
Yeah, that's cool.
Yeah.
You ready to go back?
Sure.
Okay.
Now, the nice thing is, can I use the images myself? Yes.
Oh, neat.
Creative Commons.
Well, a lot of things that come out of NASA are, in fact,
well, this isn't NASA. Domain. This is ESA.
Oh, okay. So ESA.
European Space Agency.
Yeah, I don't know how they work, but I know with NASA, a lot of them are basically in the public domain. So this is Creative Commons. I don't know how that's different or the same. If anyone out there knows, let us
give credit.
Give credit. Okay, yeah. Well, that makes sense.
Don't take credit for yourself. You can't claim that it's your image.
You didn't go out there and take it.
Yeah. Or bring it back.
Right.
So who are Churyumov and Gerasimenko? I'm sorry, you two, if you ever hear this.
Most of the time it's pretty much how it sounds.
Clemens Svetlana, two Ukrainian-born astronomers who found the comet in the photographic plate in 1969.
Oh, wow.
At the Kiev University.
Mm-hmm.
Now, can I ask questions not in this fact? Well, you can always do the talk when you're in the classify thing.
That's the forum area of the Zooniverse, right?
Yeah.
Yeah. Okay, cool.
So, and like I said, a lot of those links to the people were clickable.
Cool.
Okay. Now we get into the actual tutorial, or tutorial part 1.
Okay.
The tutorial here is kind of the introduction to the tutorial, and the field guide is the main tutorial.
Remember when you're looking at that's what you said. It seems odd that they wouldn't put all or what you need in there, or is it enough to do the task? I don't know. I didn't look at it this time.
No, the tutorial is more what's the task.
What's the task? Okay.
And the field guide is more the how to.
Okay. All right.
Yeah. So
here we go.
Yeah. So there's a lot of controls on here that we'll get into. You can zoom, you can zoom out, you can rotate, and this arrow actually points to what they've determined to be north for the comet.
Okay.
They picked a direction, and that's north.
The comet north. Okay.
Yeah. And so that helps you get the images into the same orientation so that you can look for changes. It's not as easy as they say. I'll just put it that way, and we'll get into that later.
Yeah, it's kind of too bad they didn't have a kind of snap to the similar direction.
And there's some other issues too.
Yeah, you said you were going to go to the live site and demonstrate exactly what. So these are your slides, and we'll get into the live site.
Yeah, I'll go to the live site just to show that it's an interesting project. The user interface sucks. I will just say that.
But that's a good thing to help them with. It's like, hey, could we do this with the user interface? Could we, make suggestions? I mean, you want to contribute to a real science project. This sounds perfect.
Yeah.
Because if you think of something that they can really use and update and help everybody, why the heck not?
Yep. So.
And that's the thing about a crowdsourced project. You get more brains in on the act. So, all right, here we go.
So, you've got, zoom in, zoom out.
So you can zoom in. That's cool.
Yeah. You can choose whether you are dealing with moving the image or dealing with making circles. That's these two buttons.
Okay. So you actually can toggle between them, it sounds like.
Yes. Cool. Except when it toggles on its own.
Okay.
Yes. Like I said, I'm not a fan of this user interface. Now, rotating here, you can click this button and it will rotate it about a quarter of or an eighth of a rotation. Yes.
If you run the cursor, it's much easier to see the cursor when you do that.
There's also this slider here, which will do the rotations in a much finer, much finer detail, except that it's not as fine as I would like. It jumps a lot. It jumps a lot. So
all right. So, but you do have an option of kind of gross movement as well as a fine movement.
Gross and a less gross.
Okay, great.
Yeah.
Seriously, tell them in the forum or send them an email or something.
I will probably after the show.
Yeah, cool.
It's just I was getting ready for this and was by that point so frustrated that I was just done.
I hear you.
Okay, so we can move the image around. Yellow arrow points to the comet's north. Rotate the image as much as you can. So then zooming in. This is the plus button 14 times.
Wow.
Yes, 14 times zoom.
That's really high resolution. I mean, they said they were high resolution, and boy, there's the proof.
Yeah. Well, and I would have been happier, I suppose. Well, it might be that they're not quite as good at finding images that are the same image. So they need a relatively big one. I would have been happier with a lot more smaller chunks of image, more zoomed in, so that you don't have to do it yourself because that gets clunky.
But it sounds like this is like step by step as opposed to like a slider.
Right.
A slider might be helpful because if you were able to count them.
Right.
It sounds annoying.
Well, and the thing is that you want both of them to be positioned and zoomed to the same amount so that you can tell what the changes are.
Yeah.
But, so you can do that. And you really want, once you've got everything lined up, you want to zoom in so that you can really see the changes because while there might be some really big changes that you can see while zoomed out, most of the changes are going to be zoomed in.
Yeah.
And like I said, 14 times zoom in. Okay. Here's where you've marked things like this is dust that moved. And if you see, it looks different in this area. And then here are some areas where the ridge line itself shifted. And you can see that too here.
Yep. Definitely looks different.
And they want you to mark every single change in the image.
Wow, that could be quite a lot, couldn't it?
Yeah.
Okay.
It basically, like I said, Scott, this is for you. Since you liked counting rocks, this is for you.
Maybe he's over it though.
I kind of figured that.
But really, it sounds like something you can really get your teeth into.
Yeah. You can do a lot with one picture.
Very cool. Yeah.
Yeah. With one set, you can do a lot.
It doesn't sound too hard either. I mean, it sounds like it's picking out things.
Conceptually, it's easy.
Okay.
The user interface just doesn't help a lot. So.
And there could be a lot of things to point out to them in the comparing the two images.
Yeah.
Okay, got it.
Okay, so some images, there are a lot of differences. taking time to mark as many as possible is valuable. Horizontal images or ridges, horizontal ridges might look different, but it's just basically shadows. If you notice here, you can see them really well. Here, there's just some deep shadows.
Scott does say it might be worth a try,
yeah.
Even though it might be tedious. Well, a lot of science is tedious.
Yeah,
like very tedious.
Yeah, but the user interface doesn't help.
Well, I think that's a great way to go, is to get a group of people so you can do as much or as little as you are able to contribute.
Right. And they do talk about when you're finished finding everything, you click next, then click yes if you've, and it'll ask you if you've looked for differences all over the images. And so if you have, which could take a while, you click yes. If that's not the case, choose there were areas I did not look at.
Interesting.
And this is still helpful because it shows that you're not done with the photo, so that they'll have other people look at it. Maybe they'll section it out so that the part that you looked at isn't in the data set anymore, assuming that enough people have looked at that section.
Yeah, and I think, well, I don't know about this one, but most of these universe projects have multiple people looking at them at every single image.
Yeah, and you would want to pick that, know there are places that I haven't looked, so that they don't assume that if you didn't mark it, it's not there.
Got it.
So this is basically saying, if I marked it, it's there, but if I didn't mark it, well, I just didn't have time or something. There's also where one or both images are too dark to tell anything. That's also something that you can choose. Or if the image is good enough, but you can't find an overlap, click I could not find any overlap, because it's possible that the images aren't the same spot.
Yeah. I think we actually saw one of those.
We'll see another one when I go to do the live demo.
Okay, cool.
Because it changed out from underneath me.
I see.
Well, basically, I moved the tab from one window to the other, and it kind of refreshed it.
Yeah. Okay.
And basically, if you just want a new pair and haven't marked it any differences, just refresh the browser. And basically, that is a pass. It's basically not telling them anything about it, which is better than telling them something false about it. Like, you found something, but you didn't find everything, but you're passing or something like that.
Cool.
Okay.
You're at the end of the...
Yeah. This is the end of the tutorial. Yeah, but there's still more to go. This project is optimized for control with a mouse. Maybe. But it can be done with a touch screen.
Oh, okay.
But but may be quite fiddly. Yeah. Okay.
So touch screens already can be a little fiddly, I think.
Yeah. Well, the mouse version is kind of fiddly too. So
okay.
Okay. So here's the field guide. These are the things that you're looking for: boulders, cliff collapses, dust transport, pits, probably from an outgassing. A pocket of gas erupted through it.
Okay.
Escarpment and scarp migration. And other features. Basically, you see something,
Sounds like it could be anything.
Or camera artifacts. And this is where the actual tutorial is of what you're looking for and how to mark it.
Okay.
Like boulders. They want you to mark if it disappears, from the right to the left, because the left to the right. Yes, the left to the right. The left image is always the earlier image. The right image is always the...
That's good to know. Okay.
Yeah. Basically, if you're Japanese or you're Hebrew, this will look wrong. But for most European
Arabic
readers, the left to right. So, so if it disappears, you mark it on the left one where it was, but don't mark anything on the right one. If it appears, then you mark it on the right one where you now see it, but don't mark anything on the left one. Because that way you don't have to try to match circles. They'll see that there's a circle on one image and not the other, and know that something's there in one image but not in the other. So so that's
and this is in that field guide.
Field guide, yeah.
Okay, so the field guide will explain exactly what that's about.
Yeah.
Do they actually have dates on the two images so you can kind of tell which one is earlier?
I think so. We'll see later. I don't remember now.
That's fine. That's fine.
So go ahead. And so cliff collapses. There we go. Yeah. Now this would have been better if they'd have zoomed these to the right, so the same level.
At least similar.
But at least they're the same orientation.
Right.
But this is zoomed in more here. And you see that here you've got a piece of cliff that's straight, and here there's that chunk's gone off of it. So that's what they're looking for you to. And a cliff collapse, you mark both sides. Oh, also in the boulders, if the boulder moved, you mark both images.
And that was in the initial thing. It had like a dotted circle around the spot where it had been.
Yeah, except that's not what you're doing.
Oh, okay.
There's no dotted circles.
No dotted circles. Got it.
Okay, dust transport. That's where dust moves, kind of like sand dunes.
Okay.
That's all that is. You mark where it is in the first one and where it is in the second one. And again, they didn't bother to zoom these the same. Would have helped. Pits. No pit here. There's a pit here. So something erupted. Probably just a small pocket of gas blew out, from heat from the sun. And there's a link here that talks more about the pits.
Cool.
Escarpment and scarp migration. Basically, these are ridges that just move. And usually, I think either this is a flat plane of surface, or this is a dust field and it's a dune that moved. I don't know for sure. They don't really say what it is. They can also be buried by dust. So they're saying that this is actually surface it can be covered or uncovered by dust.
Okay.
And other features, if it's not one of the above and it just looks strange to you, mark it and do the talk to them. Let them know that you found something weird, because hey, if it's something completely new and different, that'll be interesting to them.
Yeah, and almost every single one of these universes I've seen has a little talk button right in the task you're doing. And I think it travels with too, right?
Yeah, it marks the image itself that that you're
No, I'm talking about the talk button to go and talk to somebody about the images. Okay. All right, do you have more? There we go.
These are things that you can see, like these wavy bands, horizontal bands. These aren't comet, these are camera. Also, these streaks, probably cosmic ray hitting the camera at that time. Again, you don't mark these because and this is just weird. See all of these really bright pixels in the sand? This is just another camera artifact.
Oh, interesting.
So if one image has the bright pixels and the dotting the sand and the other one doesn't, that's just a camera.
Well, that's a pretty good field guide.
Yeah.
To tell you all the different. Yeah. It could be this. Could be that.
And my guess would be just different angles of the sun hitting things.
Yeah.
So that's the field guide or tutorial 2.0 for this.
Okay.
Because that's the rest of what it needs. And now here is.
Oh, Omar. Okay.
This is actual classification. This is the first image that I saw. And here are the controls. They're a bit bigger here so that you can see them. This is between moving the image and marking ellipses. This is zoom out, zoom in. This is rotate by a chunk, and this is a slider for rotating.
Oh, there is a slider. Okay. Cool.
Yeah. Now, and there, if you notice, there at different orientations. So
well,
first thing
is it even the same?
Well, that's
location?
just it. Hard to tell right now, but
yeah.
So I rotated them to be the same. And yeah, it's not, I couldn't see anything in this image that had anything to do with this image. I thought that this was somehow dealing with this, but it's just not, because this looks more like a crater, and there's just nothing like that here. If this is here, I still wouldn't be able to see anything really here.
Yeah.
And there's nothing to indicate that that's the same.
So you're basically got the arrows pointing in a similar direction. That's what
right.
Okay.
Not the same, because it's not fine enough.
Right.
But so I just picked next and then hit no overlap, which I forgot to take a screenshot of that screen, but we'll see it when I do go into the live.
Okay, cool.
Now here's the next one. Now these rocks do look a lot like these rocks. So
yeah, they do.
This is the same spot. So again, the first thing I did was try to get these roughly the same orientation.
Yep. Looks very similar now.
Yeah. And
then a lot of shadows and different.
Yeah. A lot of shadows are different. And this could be a, cliff difference, but if you notice, there is a cliff here, but the shape of it's slightly different.
Yeah.
But again, could be shadow. Zooming in is kind of what we would do. And I did zoom in a bunch. If you notice, these are the same rocks.
Yep.
But if you notice this escarpment,
okay,
changed. And so here it was here it was not here, or moved over to here.
And it could be just shadows are different.
Yeah, except that, it could be, but it looks like there's nothing here, but there is here. So I marked that, and I was working on marking more, but just the user interface just was a pain in the rear. So come back to us and all.
Okay. So
I'm gonna
frustration won out.
Frustration won out.
So do be aware.
So I'm gonna stop sharing that.
Okay.
And
I know you have another thing. So.
Yeah, screen share.
Just going over to the actual
website.
Live website, and that is right here. So if you want to check it out yourself.
Yeah. So here is the live website. Now, here we can, move it around here. If you've noticed, I've got it roughly pointed in the right direction. But here is if you notice how much it jumps here, and I'm trying to get it.
Could be finer.
Yeah, it could be finer. This would jump it a lot. Don't.
Oh, wow. Yeah. It's almost quarter, 90 degrees shifts.
Yeah. And I'm just using this as an example, because I'm not going to save it, because quite frankly, I don't think that this is the same image of the same location.
It's pretty different to me.
Yeah. So now one of the things that you'll notice is I just did a bunch of moving, rotating stuff using these controls. So you would think that you zoom or you rotate, then you move something, right? No. It toggles it to creating an ellipse.
Okay.
So every time you move something, every time you hit one of these controls, zoom in, zoom in. Or here, you zoom in here, and this one toggles back to ellipse. I mean, I haven't seen a real pattern to it, but they keep toggling to the ellipses. So when you're trying to get them set up and lined up, it's just such a pain in the patootie.
It definitely sounds fiddly.
Yeah, and you have to keep hitting the movement one if you want to be, moving around in here, because you try to go move this one and you got an ellipse again.
Okay. I would definitely go over and say, hey.
Yeah.
Is this meant to be this way?
Yeah,
it's not really working out for me.
Yeah, I would say that they really need to work on the rotation, and they need to work on, don't flip and toggle these unless I toggle them.
Yeah.
Because if I'm marking ellipses, I want to mark ellipses. If I'm moving stuff, I want to be moving stuff.
So it kind of looks like the cursor changes. Can you
Yes.
get an idea from that?
Yes, if you're, so yeah, that cursor versus that cursor.
Yeah, it's a little bit subtle, but it is different.
Yeah, but if you're like watching these controls and then going to move this, because let's say you're looking at something over here and you're moving it, you're not necessarily watching your cursor.
No.
Because I don't want to put the cursor on the thing that I'm watching. I want to put it over here. So it's just not.
I just thought maybe it was a good, an indicator of what's different, how they change.
At the very least, since this doesn't look the same to me. Although, hey, if any of you think it is the same, say something. But so I'm going to hit next, and this is that screen of, have you looked at all of the changes? Yes. And then there were some areas I did not look at. The image was too dark or otherwise not usable, or I could not find any overlap. And so I'm just going to pick that one because it doesn't look like an overlap. They look
very different, yeah.
And so
cool.
Here's another one. And there might be a bunch of these that are not overlaps, but if you notice, these arrows are like not even near each other. So let's see if we get these pointed roughly the same direction.
Yeah, they look really different to me already.
Yeah, I was wondering about this and this. But now that these are pointed in the same direction, I still don't see.
And it seems like they're not zoomed to the same place either.
Yeah, so this could be this. So let's try zooming this in a bunch. And this time it didn't toggle. Yeah, you laugh.
I share your frustration at things, though. Like they say, insanity is doing the same thing over and over again and getting different results. At least that's my version.
It's not toggling now. Okay, fine. We're live on the air and it's not toggling. I'm making a rude gesture at the screen, by the way, folks. So, okay, in any case, I don't think it's the same image, and let's go back to us. And
okay. Yeah. Cool.
I'll stop sharing that screen.
Alrighty. At this point, I want to talk to you about get your free list of annual meteor showers. And what you do is visit meteorshowerchart.com, fill in the form, press the button, and you will get that for yourself. All right. So let's see. At this point, we usually talk about some stellar events this week, but there's not a lot going on, folks. I've got July 8th through July 15th. And do remember that the planets are in the morning sky now. It's kind of changing, though. Like Mercury's not going to be there. It's going to actually shift to the evenings, I think. But they're still lining up a bit, and it will break up a little bit, and they won't be quite as evenly spaced and everything. July 13th, full blue moon, and Pluto and the moon are in conjunction. On July 15th, we're back to the Friday night show. I haven't decided yet if I'm going to tell you about a tool or some movies, so tune in to find out. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Also, on July the 15th, Saturn and the moon are in conjunction. That's you.
What phase is the moon? Are you going to be able to see Saturn well?
Well, if it's full moon on the 13th,
it'll
be a couple of days past. But Saturn's, they're all in the morning, so the moon will probably be well into the west and setting. So they'll be kind of opposite sides of the sky.
Oh, okay.
So, yeah, probably not a big deal. Okay. And Saturn's really bright most of the time anyway. So.
Yeah, I just didn't know if that would make... Okay. Ongoing events and activities.
And we found some information about this one. Finally.
Kennedy Center Visitor Complex. I need to share that again. I forgot that I had something else to share on
Yeah, let me know when you're ready.
Never mind, I already killed the window.
Oh,
Mind.
you did?
Okay, so Kennedy Center.
We have a nice picture of it, but I'll give you the link in the chat too, so you have that.
July 1st to August 7th. Visit 6 stations, then collect your prize at the information center or the space shop. And so
there's that link. It should be clickable when you get it in the chat.
There it is. So so there it is. No screenshot, but no. Oh,
what's Cliff say?
Cliff. Here. Let's see. Oh, it's finally a fantastic week.
Oh, good.
End of weather after lots of rain and cold.
Oh.
Rain again and cold. Down to 5 degrees centigrade. Yay for us in Queensland. It's cold. Might be able to get some shots of the Southern Cross. Yep.
And don't feel too bad because David said he's got lots of rain now.
Yeah.
So there you go. All right. So you see that link. It's in the chat and it's clickable. And then we got one more that's kind of been hanging around.
Oh, yeah. 9th Annual Science is Cool event. August 5th from 9 a.m. to 4 p.m. Pacific time. It's a virtual unconference for cool teachers.
I'm actually going to attend that one. All right. So let me get that link for you too.
Is that on a Saturday or is that on a weekday?
5th. I forget.
Is that, he said August or?
August 5th. Yeah.
August.
All right. Here comes the link in the chat. Should be clickable for you.
It's a Friday. Okay.
It's a Friday.
I'll
okay.
Be at work.
Oh, got it. Yeah. And yeah, it should work out with the show. All right. So, that's kind of it for today. If you or someone you know has done something interesting involving space exploration, science, or astronomy, we would love to share our live. Join us again next Friday. I'm going to decide to talk about a tool, the Clear Sky Chart, or do a review of some space-related movies coming up this summer. Do you have a preference? I want to mention, too, on the 22nd, our good buddy Neil Simmons is supposed to be with us. And on the last one, I think that's the 29th, right? 29th of July, we are going to do an open mic night again. It was a year ago that we had a guest speaker who could not join us for some reason. We still don't really know why. And we kind of just had to punt and make it a open mic night. So if you want to talk to us, we would love to talk to you. So the 29th, we're going to be sharing with everybody.
And we'll see how the signal is from Florida again this time.
Florida or was Australia?
Australia. Yeah. Don't know why I thought Florida.
Fingers crossed we can actually talk to you folks, but we will do our very best to do that. So last check on the comments, and we will stick around here for a little bit in case you do have one kind of after we clear out because there's a lag. So yeah. All right. Anything else from you?
Nope.
Awesome. Folks, have a really great week, and we'll see you on the 15th. Good night.